Video two is quotient identities. So, I kind of want you to just think about in your head now how tangent, sine, and cosine could be all related to each other. Um, and you can think of it in terms of x's and y's and r's and things like that. But if you had me last year, we kind of talked a little bit about this and how tangent is the same thing as, or can be rewritten as sine and cosine. Um, so what we did last year, and I'll just kind of rehash it a little bit, but if you can think of it even better, but basically tangent of theta, and this is the first quotient identity, tangent of theta is the same thing as sine of theta divided by cosine of theta, right? Um, and why does that work? Well, if you think about it, tangent of theta, right, was what we'll get equal to in a minute, but you can think about these in terms of y's and r's, right? So sine of theta, sine is, so opposite over hypotenuse, but it's also the same thing as y over r, right? So if you think in terms of trig and even just picture the unit circle, the y coordinate is the opposite coordinate for a triangle. Um, if the angle right here is theta, opposite would be the y, adjacent would be the x, theta, and then the radius would be the hypotenuse. So opposite over hypotenuse is y over r, right? We know sine is y over r. Cosine we know as x over r. So if you had y over r, opposite over hypotenuse, divided by x over r, adjacent over hypotenuse, right? That's the same thing as instead of dividing by the fraction, multiplying by its reciprocal. So you'd have y over r times r, hypotenuse, over adjacent, which would be x. So what you would notice is obviously the r's would cancel, or the hypotenuses would cancel, and you would just have y over x, which y over x is the exact same thing as tangent from when we did in Unit 5. So what I want you and your groups to do now is figure out how cotangent, sine and cosine, could all be related to each other using that same logic.